Um, so given we had class last Friday canceled, I don't think anything needs to shuffle too much. We're just shifting things back a little bit. The plan is to, again, release the next midterm for next week. I'll send out specific details and an announcement on Sakai, and then talk about that more on Friday. But again, the format of that will look just like the homeworks. It'll be a Git repository. It'll just be yours as opposed to Teams. You do the work there. There'll be the same kind of actions to give you feedback, that kind of stuff. And so fully expect sort of the stuff that's covered in the first three homeworks. So some data cleaning and manipulation, summarization, visualization, that kind of stuff, pulling it all together. So that's currently the plan for that. And again, I'll give you the details exactly like when it will go live, how long you'll have, but you'll have at least a week to complete it. So again, expect an announcement before Friday's class of like the exact details of that. For next week, the beginning of the week is fall break, so there will not be lab sessions on Tuesday. So we'll pick those back up the following week afterwards. But otherwise, I will be around and reachable by email if you have questions about things next week, particularly if the midterm goes live over that period. Otherwise, today we're going to sort of wrap up stuff in terms of talking a little bit more about ggplot, particularly the larger ecosystem, just to highlight a couple useful packages there. And where you go to find out more. And then we'll spend the remaining time talking a little bit about the process of designing visualizations. So what goes into a good visualization, what are you trying to accomplish there, some of the general design process for all of that. So in terms of the larger ggplot2 ecosystem, this is a very biased sample of packages. It's things that I'm familiar with and used, not to say that they are the best options or even the only options or that there aren't other things out there to do other kinds of stuff, but things that I have personal experience with that I think are useful that add on something important into the larger ecosystem for ggplot. The first one is ggthemes. So the entire display and the output of all ggplot stuff is governed by themes. And we saw a little bit last time in terms of the changes between the default theme that gives you the gray background and certain things, and theme minimal, so on and so forth. ggthemes is just a package that includes a bunch of default themes that change a bunch of stuff. So here are some examples of a ggplot, the default theme on the left, and then applying different themes. So theme minimal, theme dark, theme void. These are all built-in default themes that are part of ggplot. In terms of the ggthemes package, they provide a lot of things, particularly around making plots that look like the plots that occur in different publications. So upper left-hand corner is The Economist, Google Docs, 538, Wall Street Journal. And again, they're not changing anything about how the plots are drawn other than things like the coloring, the theming, the text and the labels and that kind of stuff. And so a lot of this has gotten way easier than it used to be. And so there's even some tools now, particularly around Shiny, which is something we'll talk about later for developing web apps, where you can do one thing in one place that changes the theme for your Shiny app as well as all your plots. So if you're working for a company that has company logos and color schemes and that kind of thing, makes it very easy to deploy across a whole variety of stuff and where you don't have to think about it much. But for like very simple, like bang for your buck kind of things, ggthemes is a great place to start. It's also, if you want to figure out how themes work, it's a really easy thing to dig in there as opposed to into the ggplot2 source code to figure out how all of this stuff works. If you're tired of R and you want to go back to Excel, you can get like classic Excel plots or even like the new Excel plots. Again, not a lot of reason for that, but again, all of this stuff is built in if you are so inclined to use. Again, not super exciting, not super sexy, but it's very useful to have those things pre-built by somebody because it takes a lot of work to create a theme that is consistent that actually works. Another really cool package is ggRepel. So very common, one of the things, and we'll talk about it a little bit in design sense later on, is it is often useful in a plot to label points, to put text on your plot, to show something, to highlight something, to indicate something is of importance. Doing that is super fiddly. So on here, I'm basically just taking the empty cars data, filtering it, and then plotting it. The left-hand side is what I get if I use the default geom text behavior in ggplot. And the default behavior, for better or worse, is kind of dumb. It centers the text on the coordinate. And so what that results in is immediate overplotting. My text is right where my point is. It makes it hard to read the text. It makes it hard to read the points. You can change things about whether it lines it on the left-hand side or the right-hand side, but note, as soon as you do that, I'm going to start getting text that runs off the right side of the left side or overlaps with other text. It's really fiddly to have to go in and like change all of those things for individual things so that they don't overlap. And then as soon as you change the size of the plot, all of that breaks and you have to do it again. So it is an immensely annoying thing to deal with. And so ggRepel is basically the idea of, well, what if we put in something that has some very simple heuristics that tries to organize the text so that it doesn't collide with other visual objects that are on your plot? And that's exactly what it does here. So literally by just swapping out one line of text or one line of code, I get a version of this where now none of my text is cut off, none of it overlaps with anything else, and it's all readable. Again, this is not going to work if you have a million points, but if you have a small number of points and you want to highlight some of them, this becomes a very good option for that. This is the very basic version of it. You can do much fancier things in terms of telling it where you want things to be placed, drawing arrows, coloring those arrows, doing all sorts of fancy things. Note here, I'm doing it for all the data points, but there's no requirement that I do that. I could feed in a subset version of the data to that, that geometry and get only those points being labeled on top of everything else, and it just works. So again, this is the kind of thing that if you try to imagine doing it yourself is a headache, a massive headache. And so it's super nice that there's just a tool there, you sub it in, and it just works. So it's super, super useful for that kind of thing. Patchwork. Patchwork is a package that's now written by the maintainer of ggplot. A couple of the packages we'll look at here. So Patchwork is a way of stitching together different ggplot figures to create something. So these are very much like if you're writing a scientific paper and you have a figure that's composed of facets where each of the plots are not related to each other. So what we've seen so far with ggplot is faceting. In that case, we're splitting our plots up, but they're sharing axes. They're being split on the data that we're using. Maybe I want to connect together dissimilar plots that are not related to each other, are not using the same data. This was possible with other tools before, but Patchwork makes it really easy with a very simple extension to the ggplot syntax in the pipe. So what I'm doing here is I'm just generating 4 plot objects in ggplot. So if you haven't realized it or you're not aware, ggplot objects are just objects, and so that's how the pipe works. The addition is just like adding things on to that object and modifying it. So they are just S3 classes that have a bunch of lists of lists of lists containing the various structures. The reason that if I just type ggplot and hit enter that it displays the plot is because the print method for ggplot is to display the plot. And so that's how it's working most of the time. We're just using the print method. But here, because I have not printed them out or haven't displayed them, we don't get any plots. They're just objects at this point. If you inspect one of them, what you see is that they're GG or ggplot objects using S3. And so Patchwork expands on some of the existing pipe tools that lets you now group together plots using some very basic math operators, plus, minus, pipe, so on and so forth. So various examples are like this. So P1 plus P2 plus P3 plus P4 creates a grid of those 4 plots together. I can then modify their behavior using the plot layout function. So if I wanted them to be put into a row as opposed to a grid, we can do that. I can change the number of columns, the number of rows, whatever you might want. Note, again, this is not small multiples. It's not faceting because they're not sharing axes in any way. They all have their own axes. They're all separate. They are all distinct. And it's not depending on the data in any way. I'm just assembling them however I want. We can also get like nested things. So one big plot with smaller ones underneath. Here now using the division operator to specify that. Or like nesting inside of other kinds of things or doing annotation. So very often in a paper, I'm going to annotate my subfigures. So subfigure A, B, C, D. Note it adds those on top of them. Or something even more complicated where I'm nesting inside and figure 1, 2, 3A, 3B, so on and so forth. So there's a lot of flexibility. But again, this saves you the effort of having to do that kind of assembly of a plot by hand after the fact, particularly around a publication or that kind of thing where space is at a premium and you need to make things as compact as possible. So again, really nice, concise notation, syntax kind of thing. So it becomes very easy to assemble very complicated figures from their constituent parts. ggAlly, again, this has been around for a while. The main reason I suggest it is particularly like 521, any kind of modeling course you're taking. One of the suggestions is the first thing that you should do before any kind of regression is look at the data, look at the relationships. So ggAlly has the best pairs plot by default that I've ever seen. It's just a bunch of facets of ggplots, things put together. But this is the same thing that you'd get out of like pairs in BASE-R, but that will only give you like the lower diagonal, and it doesn't give you a lot of useful things. It doesn't do the right thing for categorical versus numerical data and all the rest. This does everything that's the right thing, and it gives you useful information across the board. So again, all that this is doing is just giving me comparison plots between all of the variables that are in my data frame that I'm looking at. So again, this is all the pairwise relationships between each of the columns in the Palmer Penguins data set. Again, this works here when we have like 5 or 6 columns. Doing one of these plots for like a data set with 20 columns is just going to create a mess. You're not going to be able to ever read it, but you can always subset it and look at it there. But again, if you need a pair plot, this is going to be a good option in terms of a place to start to look at things. It does a much better job than most of the other ones. It is also very slow because it's generating a bunch of individual ggplots, which are slow in and of themselves. So for a large data set, it will take a while, but it's a one-off thing. Then you have it, you can look at it, so on and so forth. ggAnimate. This is also a super cool package. What it does is it takes the basic ggplot implementation and then adds additional verbs that will allow you to create animated versions of those plots. So there's a lot going on behind the scenes. There was an earlier version of this package that was a little bit simpler, and then it got rewritten from scratch, basically. And so it's incredibly impressive now. So this is just one of the examples from the wiki page on the repo. But the difference between this plot and the static version of it is literally one line of code. And so all that this is basically saying is, with this plot, for each of the unique values of day, draw a different version of this, and then stitch them all together. And so what it's doing here behind the scenes is it's creating an animated GIF. So it's just rendering each of the individual frames, one for each day, and then stacking them together to create the animated version of it. There's some other parameters you can tweak about like how fast it runs, how many frames per second, so on and so forth. But it's unbelievably powerful what you can do. And there's a bunch of complicated stuff and a bunch of simple things. But for the most part, it's literally just adding one line of code to indicate where is the time domain going to show up, what do we change, and then it will just render the things and stack them together. So very much take a look at the website. So in particular, there's the wiki page here that has a bunch of examples that you can take a look at and how it gets used for rendering things and that kind of stuff. But it's one of those things that you can take it as sort of shallowly or deeply as you want, because you can get really in the weeds and do a bunch of crazy stuff, or get very impressive things by just adding like 1 or 2 lines of code to get stuff through. So it's absolutely worth playing with and figuring things out, because again, this lets you show more information in a plot than what you can do with just the axes. It's another very powerful domain to add an additional dimension to your data. And so if you're interested in these or other extensions, my screenshot here is now out of date. I think there's like 130 now. But part of the ggplot2 website is this extensions page where anybody who's added an extension to ggplot, so basically a package that uses the ggplot objects and extends their functionality, can post and provide information about it, and then people can interact with them. So there's a bunch of options here that you can play with and take a look at. So I think here they're rated by some kind of voting system of like popularity, I guess GitHub stars. So you can get some idea of who's using what, but just browsing through here and seeing if there's something interesting or something to play with. There's a ton of interesting options there to take a look at and play around with. So Patchwork, ggAnimate, things we talked about, ggREPL, ggGraph. So if you're working with graph structures, you need to render those. Force, I'm not sure what that is. This is another collection of themes, but again, there's a ton of options out there that are super useful. So a good place just to poke around to see things and learn new and interesting things. Okay. So if you're not familiar with it, Thomas Lynn Pedersen is a employee of our studio now. He used to work for like the central bank somewhere in Scandinavia, Copenhagen, maybe in Denmark. He's now the maintainer of ggplot, but basically anything that's like super impressive in ggplot recently, it's all his work. He also does some really cool stuff around generative art. Follow him on Twitter. He's a super interesting guy. But there's a ton of important work that's going on there that he's doing in that space. So he's basically wholly inherited that package from Hadley at this point. Okay. So for the remainder today, I want to talk a little bit about visualization. Why do we do it? What's the point? How do we do it better? That kind of thing. And so we'll sort of build around that kind of thing. I am not an expert in any way in this domain. I'll try to wrap it up with, here are other people who know a lot more about this and other resources that you can pursue, because again, this is the kind of thing that I cannot remotely do it justice in an hour. If you're interested, the department will be offering a visualization course. It's an undergraduate course, but I believe as MS students, you can take that and still get some credit towards your degree. There's just a finite number of those classes you can take. But there's an entire 15-week class on visualization that tried some of the ground we've covered, but then goes a lot deeper. That'll be offered in the spring. Okay, so we're going to start with why do we bother to visualize data in the first place? What's the point? What are we trying to do? So if you know and recognize this name, that will give away the point I'm going to make. But we're going to start with this data set called Anscombe's Quartet. So this is built into R in the datasets package. It comes in a weird format. So just by way of practicing what we've done so far, this is not a tidy representation of this data. So what we have here are 4 data sets, each with a set of 11 observations of X and Y. So currently it's in this weird long format, but not even a good long format, wide format. So we want to rearrange it and organize it. So I'm going to abuse some tidyr stuff, pivot it, split it up, to ultimately end up with a version of this data where I have the variable under the group column. So there's 4 of those, and then X and Y for each of them. So and then in that case, 44 rows of data because 11 observations for each of the 4 groups. So again, we look at these there's not a lot of obvious structure here. It does seem to be for X1, 2, and 3, all of those values are the same, but then the Y's are different, but they're in a similar ballpark in terms of range. X4 is different. There's a lot of repeated 8s. But it's very hard to just look at the table here and get any sense at all in terms of what's going on. There's something suspicious because there's duplicate data, but beyond that, I can't really say much about it. Typically, what we might do is something like this, and the first thing you might do is to do summary statistics. So let me just summarize this, calculate the mean of each of these values, the X and the Y, calculate the standard deviation, and calculate the correlation. Those are 5 reasonable summary statistics to have. And if we do that, something funny happens in that all 4 of these groups, they are different from each other. The Y's are different, but they all have the same mean for X, the same mean for Y, the same standard deviation for X, the same standard deviation for Y, and the same correlation, at least out to 2 significant digits. So they're very close. And so in that case, if I just looked at the summary statistics, I might conclude these 4 things are the same. But if I do at least look at the data, I'm okay, they're similar, but they're not exactly the same, so it's kind of odd that they're exactly the same mean. Really, the only way to get a good sense of these and to figure out what's going on is to have both the summary statistics, but also a visual version of it, because looking at the table is not going to tell you the story. And so Anscombe's Quartet is an artificial data set that's made up, and it's made to have that exact property we just saw. It's designed to have the means the same and the standard deviations the same and the correlations the same, despite having very distinct patterns and structures in the data that are different from each other. And the point is to say that single number summary statistics do not tell you the whole story. You're throwing out data when you calculate those, and you can't see the big picture with that. They're useful. They tell us a lot. Statistics does a whole lot using means and standard deviations, but that's not the whole story. And visualization is a much more information-dense way of presenting things to people where you can then see what's going on. So I couldn't really tell what was going on with the X and the Y's in the table, but right away from 1, I can see that, okay, this looks like a positive linear trend, the kind of thing I might fit a linear regression to. That's fine. 2 is clearly a quadratic trend with no noise. So in that case, fitting a linear trend makes no sense. It's the wrong thing to do. But again, if I'm only looking at the summary statistics, I might conclude 1 and 2 are the same. They're not. They're definitively different patterns going on and different things that are not being captured by what I'm seeing there. Similarly, 3 is a very simple linear trend with 1 outlier. Linear trend with no noise and then 1 value that's completely crazy. And then the 4th one is the worst one, where it's just the same value repeated except for 1 outlier, but that's an influential point, so it drags the line out, gives us that correlation that's kind of spurious in that particular case. But none of these things are particularly obvious other than maybe 4 being super weird by inspection of the data alone or looking at the summary statistics. You really need to look at the visualization to see what the pattern is. And at some level, that should make sense. We're a species that evolved over millions of years to have a very good visual cortex. A lot of our brain is taken up with processing visualization, visual information. We're really good at that. Our brain does a good job of that. And so even for representing quantitative information, that is how our brain does pattern recognition better than anything else. We're evolved to look at pictures, not to look at tables. And so we can leverage that to do a better job to figure out what's going on by creating a picture that our brain can interpret. With that said, one of the things we need to keep in the back of our mind, though, is like, what is the goal? So we are representing quantitative information. There are numbers behind it. So we want our brain to be able to recognize that and pull things out. And there are certain things that our brains are better at doing that for than not. What we're doing right now is we're mainly just using position, X and Y coordinates, to indicate where the data is. Our brains are good at that. We're pretty good at recovering the information there. There are going to be other tasks that we're not so good at, and we'll point those out, and that's where there's going to be decisions that go into the design of like, what do I represent using what particular aspects of visualization, because there's going to be a hierarchy of what is my brain good at versus what is it less good at in terms of recovering that quantitative information, recognizing patterns, so on and so forth. Okay, so that's Anscombe's quartet. Maybe 4 or 5 years ago, there was a researcher at Autodesk who came along and said, like, okay, that's cute. You can make some lines and they have the same mean and the variance. I bet I can do better. And so he came up with this thing called the data source dozen. And so this is the exact same thing where these are all plots of different sets of X and Y, but they all meet more or less that same requirement where the mean of X, the mean of Y are the same, standard deviation of X, standard deviation of Y, and the correlation. And again, the point is just to make this extreme thing of we can draw a picture of Tyrannosaurus Rex and it will have the same property as random noise, as a star, as a bunch of lines, as a bunch of these other kinds of things. Summary statistics do not tell the whole story. So it's getting overwritten here, but you can follow the link on the slides. There's the original paper about how he did it. So all of this started with the drawing of the Tyrannosaurus Rex, and then he used like an iterative solver algorithm to like optimize the problem to come up with a solution that looked like something else while also having the same constraint of the probability, those summary statistic properties. So it's a cute kind of thing, but again, it makes the same point of what we're looking at here in terms of this is a problem. The only thing that you can do is visualize the data to try to get some sense of it. This works pretty well for two-dimensional data. When we start adding dimensions, it gets harder. Our brains are not as good as that. So again, we'll talk about various strategies in terms of including multi-dimensional data to visualize more complicated patterns a little bit. So again, just to highlight like this specific examples. Again, all 3 of these have exactly the same mean, standard deviation, and correlation, at least up to a couple sig figs. And if you want to calculate them, so again, this is in the data source package in R. You can download them, but again, that's the summary table on the right-hand side of each of those values. So again, correlations are not quite as good. He mostly went for 0 correlation, but again, pretty impressive that you're actually able to do that. Okay, one other example here where, again, to emphasize that even the visualization is not enough some of the time, but it will help, is another sort of common thing we bring up in Stats 101, which is Simpson's paradox. So in this case, if I were to just look at the X and the Y, it doesn't do a great job, but it maybe is not totally unreasonable to draw that line through it in terms of like, this is the average pattern that I'm seeing in the data to fit a linear regression to it. But again, visualizing, you do see that there's some structure that clearly that is not accounting for. Like there are some bands, why is that happening, what's going on? And so Simpson's paradox is particularly this idea of if I have a confounding variable that I'm not taking into account, I can often get the opposite result of what I'm expecting or what the actual pattern is. So in this case, if we were to take into account that each of these bands is its own group, I get regression lines that all have negative slopes that are decreasing. So it's showing a negative relationship. Versus if I remove that grouping variable and I don't take it into account, I get an answer that tells me the slope is positive and increasing. So it's completely opposite of the result that I should draw. And sort of it's a cautionary tale about watch out for confounding variables because they can completely screw you up, not so far as to estimate the coefficient wrong, but to get it completely backwards from what it should be. At least in this case, though, we're doing better than just fitting a regression line and saying the fit is not terrible, because we can see that there's patterns that that regression line is not accommodating. And so the visualization at least helps a little bit there, but coloring it by the other points makes that point really clear. So if I'm adding that third variable, the grouping variable, it makes it abundantly clear that this is a problem that needs to be addressed, and that maybe including that as a coefficient. So adding that or adding an interaction term becomes a very good option, maybe to take that into account and get the right answer. in this particular circumstance. And so this is a contrived example with fake data, but there are very real-world examples from like graduate school admissions at Berkeley and other cases where there's instances of Simpson's paradox taking place and people drawing the wrong conclusion by not accounting for some of these other effects. And they can be very non-intuitive if you're just looking at the summaries. Okay, so that's sort of like why we care about this in the big picture. So then how do we do this? One of the things to keep in mind with visualizations, and again, like some people like feel a little bit uncomfortable about this, but a visualization is visual storytelling. You're trying to convey a message to an audience, and you're trying to do that effectively. And you can interpret that in a variety of ways. Yes, you can lie with visualizations, and I haven't bothered to like pull together a bunch of examples of like lying with bad visualizations, like hiding the axes, like truncating the axes, all sorts of crazy things that you can do, misreporting scales, that kind of stuff. So absolutely you can lie with visualizations, you can lie with statistics, you can lie with anything, but that's not to say that when you're constructing a good visualization, you shouldn't have a point of view, you shouldn't have a goal in mind, and you shouldn't be trying to convey that as effectively as possible. And in order to do that, you need to understand a little bit about who your audience is, how you want them to use it, what they're going to be good at or bad at, what they know, what they understand, what they don't. All of those kinds of things are really important considerations that go into the design process. And it's not just sort of a, here's the one-size-fits-all rule that you can apply. Like I can't just use ggplot out of the box and get a great visualization. I can do that to get a pretty good one. I'm going to have to think a little bit more about those and specialize them a little bit. So what I want to go through with this is just some of the considerations around what are good practices or bad practices, how do we improve visualizations to make that a more compelling, a more effective story that we're conveying to some kind of audience as we go through. Okay, so the link here is not working for some reason. I will restructure the slide just to have the link present, but this is a video from Hans Rosling from a number of years ago. He sadly passed away a couple years ago. He's also had a very famous TED Talk that went through the same domain. This is the fancier high production value version of that. But he ran a project called Gapminder, which is about sort of understanding the relationship and the economic development of different countries across the world. So I will play this video. We'll go through it. As you're watching it, pay attention to the visualization. Think about what is he trying to convey, and then how does the design of the visualization he's presenting work towards that goal. So that take a step back and think about that as we go through, and then we'll try to dissect it a little bit step by step as we go.
The world my father told me about 50 years ago was a divided world. It looked like this. Each bubble is a country. Size is population. Blue, Africa. Red, Asia. Yellow, Europe. And green, the Americas. Vertical is child mortality. From 30% of children dying before the age of 5 down to almost zero child death. Horizontal, number of babies born per woman. From 8 to less than 2. But most countries were up here. Women had 6 to 7 children. Child deaths were frequent. Almost every family lost one or more children. In many people's mind, the world still looks like this, developing and developed. But it's a myth, because the world has improved immensely in the last 50 years. Here we go. Year by year, child mortality fell in almost all countries, and as child mortality fell, women chose to have fewer and fewer babies, and that enabled them to invest more time and resources in each child. By 1990, some of the so-called developing countries had already made it down here. Some were in between, and a few remained up here with very high child mortality. Ethiopia had hardly moved at all. It had passed through decades of famines and political turmoil. Many people think that Ethiopia is still stuck up here. But look what happens after 1990. With improved access to health service in rural areas and well-spent aid, child mortality falls dramatically in Ethiopia. And with better access to family planning, women choose to have fewer and fewer babies. Ethiopia has come halfway and is moving quickly down to this corner. But Ethiopia still faces many challenges. I will split the Ethiopian bubble. The capital, Addis Ababa, is already down here. But the remote Somali region of Ethiopia still have high child mortality. But most of the regions, 90% of the population, are centered around the average. Most people think that the problems in Africa are unsolvable. But if the poorest countries can just follow the path of Ethiopia, it's fully possible that the world will look like this in 2030. Then there will be no countries left in the box we once called the developing world. But to ensure that that happens, we must measure the progress of countries. It's only by measuring we can cross the river of myths.
So I'll come back, talk a little bit about the overall project Gapminder in a second, but let's go back and look at the visualization.
But most children.
So a couple things in terms of the starting plot here. Let's think about how many dimensions, so how many different variables are being displayed in that visualization. So x-axis, babies born per woman, y-axis, child mortality. What else do we have? Population in terms of the size of the points.
Region in terms of the
So the
color.
points themselves are also the country, so that's another one.
Region in terms of color.
So the continent, it's 5, and there's one more.
Income.
So the year. So in that case, that's the animation. So each sort of frame is then an actual year. That's 6 dimensions shown on a scatter plot. If I tried to show you all 6 dimensions at the same time in a 6-dimensional object being projected into 2-dimensional space, you wouldn't be able to make heads or tails of it. So in this case, it's very selective in terms of what we're showing, but by virtue of picking out the various features that we're using, we can cram a huge amount of data into a single visualization while still keeping it readable, understandable, visible. One of the other points is also in terms of the hierarchy of what is being mapped where and how. So things like the country to split things out makes sense, like the group by things, the individual rows of the data. The continents, it's not a super important point, but it's useful to see something about what's going on there and like seeing what's related to who. So in that case, color is something that our brains are pretty good at picking up, matching things that are similar to each other, but it's not something that is super critical to understanding what he's trying to make, so it's a less sort of important feature that shows up there. Also note that there's not like a giant legend on the right-hand side telling you like which one is Europe and which one's North America and which one's Africa. When it's relevant, he points out and references it in the speaking, but again, we're not losing a bunch of space to something that we're not using regularly in terms of that lookup kind of thing. The motion and the animation to emphasize time is a very natural and useful kind of thing. And again, that helps you see so much more data because you can flip through these things over time. Other sort of interesting features to point out is doing something like this. So selective annotation, both on the axis itself as well as individual points. So again, we cannot label all 190, 200 some odd countries in the world and have any that make any kind of sense at all. So they very purposely selected out certain countries to highlight that are then following their trajectory. So you can see China, India, Iraq, Nigeria, Ireland as sort of things to follow. You could label more or less, but fewer is more than more in this particular instance because it doesn't then complicate things. Yeah?
Do you know what tool or language they use to make that?
I have no idea what the underlying thing is. If you've seen his TED Talk, on the website itself, they have the Gapminder tool, which is something they wrote custom for it, which does this kind of thing. You can pick the X and Y axes and then animate it and watch it go through. But yeah, this one, it's probably something custom out of a graphic design house kind of thing. I would not be surprised if it started as something that you might recognize, but then like you import it into After Effects or Adobe Illustrator. Not for this, but a couple people I know who do sort of professional visualization. So blanking on his name, he runs a blog called Flowing Data that does a lot of stuff about visualization. He does all of the initial work in R, exports them as a PDF, brings them into Adobe Illustrator, and then tweaks them by hand because that's how you get the nicest looking stuff. And that's a common workflow for places like the New York Times and other places as well. But usually having something to get you a starting point that you can then either trace over or turn into some kind of like Illustrator-like object is typically how it works.
That's the thing to figure in the economists doing that is like, you know, be very complicated with the
Yeah, very likely something like that. But also realize people like The Economist, New York Times have like a full-time development staff that just work on those kinds of things. It's a non-trivial amount of work. Yeah, so the individual labeling of points, that gives you some grounding and anchoring to pay attention to, so you can follow their trajectories and see what's going on. If they were all sort of undifferentiated points, your brain would follow the bigger ones probably, or the ones that are brighter colors. So like the yellows, the greens, maybe the reds, probably less likely the blues. But this gives you some anchoring and tells you what to pay attention to. And the other bit is the annotating of the actual axis. So showing the developing world to the developed world is a very important point that he's trying to make. So he's trying to show that trajectory of where they started, where they went. You lose that by moving things through time, but this, again, emphasizes the point that he's trying to make in terms of this development process that's happened from the 60s up to 90s and early 2000s in terms of how much they've moved, showing where they started, where they ended by a simple annotation or simple background kind of thing. And there's a similar kind of thing when he's pointing out for Ethiopia with, again, removing all the other highlights, showing where Ethiopia started in the 1990s, and then showing that trajectory to emphasize one particular country to make it more impactful. And then again, changing some of the countries that are labeled to, again, give you some context and comparisons that he would like you to make as it goes through. Other kinds of stuff. So this is a similar point to what we were trying to make with the summary statistics and Anscombe's quartet. Visualization and aggregating to the country level, you're losing information at that point. You're collapsing things down, you're making it simple. And so something like this, where we explode out Ethiopia to show what different regions are doing and how that difference there, showing the variability in that data is an incredibly powerful idea. To again show that even within a country you might have a particular preconceived notion about, there's vastly different levels of these particular socioeconomic development indices kind of thing. So the difference between Addis Ababa versus the Somali region. And again, that's very powerful. Note what he's done here too, though, is kept the original labels and the anchoring, kept the data. So the other stuff, it's hard to see now with the lights on, but all of the other countries are still there. They're just faded into the background because the point he wants you to make is the comparison with Ethiopia, but you still have all that data from the other countries as well to make a comparison. So again, letting people look at everything, have that context, but then using the intensity or the fading to emphasize what you're supposed to be looking at this particular point. Is there anything else wanted to point out? I think that covers it. So again, this is an incredibly polished version of this, a huge amount of time and effort. And again, you'll find many, many different versions of this talk. There's the TED version and all that other kinds of stuff. But I think you have to admit that it's a fairly compelling case for this, and it's probably one of the most effective visualizations you're likely to see anywhere in terms of conveying the story that he's trying to say. He has a very distinct point of view. He's trying to convey something, and he's trying to do it very effectively. So this is often referred to as the Gapminder data set or the Gapminder visualization. So you'll see it in various places. You can download it and pull it up. So again, on their website is this understanding visualization with the animating data, and you can go into that and play around with it yourself. It's a whole web app with these kinds of things. So that's not what I want. You can do the same thing. So in this case, it's different axes. You can change the X and Y, so it's interactive and kind of cool. So just to give you some larger context about what he was trying to do and what this foundation is still trying to do. So it's trying to convey to world leaders and people around the world about what is the state of affairs of economic development. And they put together at some point, and I forget, it's a very simple quiz. It's like 5 questions or 10 questions that they would give to school children, political leaders, business leaders all over the world that essentially got at like, what is the current state of the world in terms of economic development? How well are people doing? How different are developing countries from developed countries, so on and so forth. And what they found is this incredibly depressing result of everybody got it wrong. People had a much worse view of how the world actually is compared to how it actually how they think the world is versus how it actually is. And so his entire life mission was like, how do we correct these preconceived notions people have about the differences between the developing world and the developed world? This is one aspect of it. The survey is one. They wrote a book. Again, it was his life's work before he passed away. His daughter still now works with it. But I do want to point out one of the other really cool projects that I think counts as visualization but is not sort of obvious is this project they put together called Dollar Street. So I was at a stats education conference where his daughter came to speak and was talking about this particular project. And so what they did is they hired photographers. They sent them around the world to all the different countries, not all the countries, but a ton of countries. And they went and interviewed individual families. They asked about how much money do you make per month? And then they had a list of things that they wanted to ask them about. So here you have this drop down of various things. So in this case, like, went to the family, interviewed them, asked them these various questions, and they asked them, okay, if you have kids, what are your kids' favorite toys? And they asked them to take a picture with that. And so every single question they asked corresponds to a picture. So what does your bathroom look like? Where do you sleep at night? What is your favorite toy? What do you use to brush your teeth? And they took a picture of that family with that thing. And all of that is then recorded with the photographs and then the amount of money that that family makes per month. So that's what these numbers are here. And you can scroll through it. So the Dollar Street that they're referring to is this thing on the top. It's the axis of money made per month in dollars. And the idea then is to compare, you may have preconceived notions of how somebody in a particular country lives. This lets you filter for that particular country and also how much money people are making within that country and then compare their life to yours, because this is something that's fundamentally about where you live, your house, your family, that you can then relate to ideally in some way. And so super interesting to play around with and look at. But the data here is fairly minimal. It's just like that dollar amount and then the pictures and everything else. But that makes a much more profound impact on most people than reporting like in a table that this is what they have, that this person's favorite toy was a Barbie doll. Again, the picture makes it much more human, much more impactful. And again, this is part of their overall mission to convey this kind of thing. So I encourage you to play around with it. It's super interesting. It's a super interesting project. That's outside of the realm of what you might normally think of data visualization, but it is fundamentally data-driven behind the scenes and is quite impactful, I think. So play with that, different kind of thing, less directly relevant to the stuff we're talking about, but definitely worth your time to look at. So we saw a very good example of a visualization, talked about some of the features of what made that a good visualization. So let's look at some other things then about like what are some simple rules, simple heuristics that you might then have or to keep in your mind as you're designing a visualization that will build on what we've seen so far. Question? Or no, okay. First thing is keep it simple. Adding more is not going to make your visualization better. So just because Microsoft Excel will let you make a 3D bar chart and 3D things look fancy, that's not a compelling reason to use that as a visualization. And in this case, like we have the pie chart, we have the labels, we have the colors. There's a bunch of redundant information here that is not remotely necessary. In this particular case, I can do exactly the same thing with the plot on the right, and the one on the right is easier to read, more compelling, more useful across the board. Again, it's not as flashy, it's not going to like stand out in a PowerPoint presentation, but the point of a visualization is not to stand out in a PowerPoint presentation, it's to convey some information. So in this particular case, again, this is made up data about like expenditures of a company on different areas, but the bar plot is going to be a lot more useful for comparing things, reading things, getting numeric values out of this than the pie chart is going to be. If you really cared about this, also you could just put it in a table. 5 numbers is easy enough for us to wrap our brains around and do calculations with. That's totally fine if you wanted to be very precise about it. We can read it off that bar chart, but we will get fairly low accuracy when we're doing that. With that said, you'll also hear from statisticians, people who do visualization, pie charts are never the right answer. You should never create a pie chart. And it's important to like explore why that is. Why are pie charts bad? Because our brains are not very good at judging the relative area of sections of a circle. Okay? So what I have here are 3 different pie charts showing different distributions of the data. And you'd be really hard pressed to tell me like what's different between these. Like what am I supposed to get out of this? Are they different? Are they the same? Clearly they are slightly different. The areas vary a little bit, but you'd be very hard pressed to tell me how much they differ from one another. So compare that to the equivalent plots when I do it with bar plots. Makes it much clearer that, okay, in this case, for the middle one, they're all about the same. It's uniform. The one on the left, they're increasing. The one on the right, they're decreasing. So our brains are much better about getting quantitative information about reading the position of a bar than they are about judging the area of a relative wedge. If we only want to do relative comparisons, a pie chart is not the worst thing. If you just want me to say that one is bigger than the other one when there are gross differences between it, it can be effective at that. But again, you're throwing away a bunch of information to do that, and it's not really, again, accomplishing a whole lot. And again, as soon as you get more than like 3 or 4 or 5 segments, your brain is really bad at it then, telling them apart, keeping track of them on all the rest. So they're just a poor choice across the board for a number of reasons. One other thing is, again, we often use color just to like distinguish things, but in this case with the bar chart, the colors are redundant. I already have labels on all of the axes, so the x-axis is that variable. It's the same thing as the color. So in that case, it's not adding any additional information. Maybe it looks prettier to you, and that's a valid reason for doing something. But again, depending on what I want to happen with that plot, you can use color much more strategically to draw attention to something. So in this case, again, this is tiny. I can't even read it on my screen. Again, this is that same plot from here in terms of like allocation of resources for a company. If I'm trying to make a point where I want them to make a particular comparison relative to building and administration to the other things, then highlighting that in red makes it more visually salient. Your eye gets drawn to that. You're more naturally going to do that automatically. Versus if you don't do that, I'm guessing about what you want me to make the comparison with. And so again, directing people's eyes to where you want them to pay attention to can be done very effectively with color. We're pretty good about distinguishing categories with color, but again, not as good. So again, that's the kind of thing to keep in your mind in terms of making those kinds of choices. Telling a story. So again, what is the point of a visualization? So this is data from Duke. It's actually real data from a number of years ago of the number of people who were hired at Duke across 5 years or 6 years from 2010 to 2015. And each line is just representing the number of people who were hired at each point. I can do this. I've overlaid them on top of each other because there's clearly like a seasonal pattern to when Duke does the hiring. Like there's the fiscal year, and we can see like most of the hiring happens in July. So the choice of overlaying the time series on top of each other emphasizes that as opposed to showing it over a long period of time. That's a choice. But the point here also is I've colored all the years. And again, the typical behavior is if it's there and I'm showing it in the data, I probably want to emphasize that and I should label it. That's the most honest thing to do. But in this case, do we actually care which year is which? Do I expect the user to look at this and to know exactly like how many people were hired in 2012 in May? Maybe, but probably not. If the point here is to emphasize that most of the hiring happens in July, I don't care about the actual year. So in that case, de-emphasizing that in some way by overwriting it, not including the legend, not including the colors, makes that a little bit more visually salient, makes it more clear that that's the point of this visualization. Again, in that case, you'd probably want to include something like this at the top with the text to indicate these are the years covered. So we do know that it is 2010 to 2015, but I don't particularly care about the individual years, so I'm not going to then make something special for that. And then things like the annotation, adding the text to it to make it very clear now what I want you to get out of this plot. So that also helps. Leaving out the non-story details. Again, this is another sort of like hairball kind of plot. And if you're familiar with it, it's very clearly made in Excel. So in this case, this is some kind of like a subject was injected with a drug, and then they were measured a response over a period of time, like after a couple seconds. And in this case, we have injection 1 up to injection 16. First of all, coloring 16 different categories is never going to work well. Like there's not enough colors that are distinct from each other that we can tell them apart. So it just becomes a mess. And in this case, what we also have here is not 16 sort of independent things. We have replicates. We're just repeating the same experiment 16 times. So in that case, what we probably care about is the average and then the standard deviation. So in this case, rather than showing all the data, I can show you each of the points and then show you the summary statistics. Or I could show a ribbon plot, or I could do some other kind of thing to emphasize that, as opposed to just showing you a bunch of lines on top of each other that don't mean much. And again, in this particular use case, I do not care what happened at second 2 for injection 15. I have no intention of recovering that information, so I don't need to make that possible for my user. That's not important. I want to emphasize the overall pattern, so collapsing in some way is sometimes warranted. Another sort of useful thing to think about is how we order our data. This is something that the tyranny of ggplot is any categorical variable, whether it starts out as one or not, will be treated as a factor. So if you give it a character vector as input, it will get coerced to being a factor. When it does that, the default behavior in R is to order the levels alphabetically. That may be what you want, it may not be what you want. So again, depending on what you want the usage to be, how you present the data should change. So in this case, the ordering of the y-axis has no intrinsic ordering. There's not a way in which we need to put them. So the two options on the left is using alphabetical order or ordering them by the magnitude of whatever we're plotting. So in this case, the sales by state. Your choice here very much depends on what you want the user to do. If I wanted somebody to look up the particular value for a particular state, the one on the left is going to be better. Because of an alphabetical order, we can do like a simple search to figure out where something is. So if you ask for New Jersey, I'm going to start in the middle and then move up or down depending on if I'm like ahead or behind that letter, and I can find it fairly quickly. Probably though, the more useful or the more likely use case is I want to compare where we're doing well and where we're doing badly in terms of sales. So I want to know where the most sales are happening and where the least sales are happening, and I want to then do comparisons between that. So in that case, ordering it by where the most are to the least makes more sense there. Trying to find an individual state, so trying to find New Jersey is going to take me a lot more time on the right, but if I'm just doing comparisons and relative magnitude comparisons, that's going to be the better option. So again, thinking carefully about what the use case is going to be, what I'm trying to convey, dictates how I do things like this. And again, I don't want to just go with the default every single time because that's not always the right choice. And so in the case of ggplot, if you want to control that, you need to create the factor ahead of time with the levels in the right order so that they appear the way you want them to appear. Other stuff is dealing with things like missing data is non-trivial. You want to be conscientious about how you do it, how you show it or don't show it. So this is just a couple of examples of different ways that you might do things. So the one on the left is the worst possible thing where maybe the NA is recorded as a 0, even though it's not really a 0. And that gives you like a false sense of what's going on there. And that's absolutely not the right thing to do, so you don't want that. You can do things like interpolate. So in this case, they just linearly interpolated. They just drew the line through it. But in that case, that's ignoring the fact that you don't have a data point there. And if I'm not also showing dots where the data were observed, I may falsely conclude that we did in fact have an observation for like 1890. And that's not the right inference that I should be making there. So we need to be careful about that. I could leave it blank, or if I'm going to do the interpolation, I could color it in a different way to imply like there's no data here, but this is what we think might have happened, or how we fit it together. Inherently, in any kind of time series, there's going to be some interpolation. I'm connecting the points. If I'm drawing a line plot, that's fine. But again, you want to be clear about where the data is and where the data isn't. So in this case, having both a line plot but then dots on top is often a good choice to make that clear where the data is and where you're interpolating. Another useful thing to do is reducing cognitive load. The example here is if I create the bar plots vertically, which is usually the default behavior, the labels are long and I can't possibly fit them horizontally. So I could have them fully vertical, which sucks to read. That's really hard. You have to turn your head. We can make it a little bit better. So again, ggplot and most of the plotting things will let you change the angle of it. So I set it at 45 degrees. It's not too bad. You can read that relatively easily, but it's a little bit, again, a little bit of cognitive load to like map from each of these labels to the bar. Like you have to move your eyes a little bit to go through that. The much better solution is just rotate things. Put the labels on the x-axis, make them horizontal, makes them much easier to read, much easier to directly connect to the data that you're trying to do that. And so cognitive load is just the amount of work you're asking of the reader to do to get something out of your plot. And the lower you make that, the easier time they're going to have with it, the more they're going to get out of it. And so again, these are just very often low-hanging fruit in terms of organization. So make text easy to read, don't overplot things, keep it horizontal, so on and so forth. Other stuff, and again, these are simple rules, but they're easy to not do. You can have a plot title. It's a good idea. Make the plot title tell you what you're supposed to get out of the plot. Telling me that you're plotting accuracy versus color and shape. So again, this is like accuracy of recall based versus various characteristics. Again, telling me accuracy versus color and shape is redundant. I can get that by looking at what the x and the y axis are. It's not giving me any new information. It's not adding anything. And if it's not adding anything, it probably shouldn't be there. Instead, what you can do is something like this. Accuracy improved by color but not shape. That tells you the conclusion right away. And I can read that, say, oh, okay, let me look at the plot and see if I can assess whether I believe that's the case. Does it convince me? So on and so forth. So using that or having the legend text, or not the legend text, like the figure text right below it to make it explicitly clear, this is what you're supposed to get out of it is a very good idea. Tell people what they're supposed to do. They don't have to believe you. You're providing the evidence there. But again, it makes it much more compelling, much more sort of straightforward to figure out what's going on. Another example is annotating figures. We saw this in the Gapminder data. But again, you don't have to make it all one color. You can use color to give people visually salient information about where they should be paying attention. So in this particular case, this is the history of Apple's stock price, which is dramatically out of date at this point from 2003. But what they've done here is tried to annotate on top of that stock price what important events happened with the company to indicate what was going on. So in this particular case, like this is where it was above 100. We highlight it in a different way. We've got these vertical bars and labels to indicate when important products were released. And then there was this precipitous drop, but that's not a big deal because at that point the stock split for 2 for 1. So all of those things, again, give you some context to read and figure out what's going on, as opposed to looking at it saying, oh, there's a weird drop. I wonder why that is. I need to Google it and try to figure out what's going on. So again, provide your reader with context and do it in the plot so you know what they're trying to get, what's relevant when they're going through it, as opposed to having to resort to outside resources or going to your figure caption to read it, that kind of thing. Again, you're limited by space. You can only put so much there, but it's a good idea if you are able and you have the room to do it. This is a similar thing, again, also to what we saw with the Hans Rosling story, where he was using the full data set with then highlighting some subset of it to tell the story. The full data set often doesn't tell a story. It's too much. It's overwhelming. It confuses matters. So this is an interactive New York Times visualization from 2014 talking about the recession around 2009 to 2011, whatever that was. And so the visualization's a little bit complicated because it's like a time series, but not really a time series. So you can go and look at it and pull it up. Is it not working? Oh, well. Let me make it bigger. So what we have here is each individual line is an industry in the economy as like monitored by the US government. And on the x-axis, we have the wages paid by that industry, so lower to higher from left to right. And on the y-axis, we have the jobs since the recession, so basically whether that industry has lost jobs or gained jobs. So implicit in these lines is like a movement through time, but time is not explicitly a variable that's being shown on the axis. So these values of their wages are changing and their number of jobs is changing. That's what the line is, but it's not like a function, so it can double back, it can move any which way. The point is, if you show this for the entire US economy, you get a hairball that doesn't tell you anything. It's like, yes, some industries got better and some industries got worse. Some paid more, some paid less. There's generally like an outward spread kind of thing of like maybe higher wages are decreasing, some are going up, but there's just variability there. It's not a clean story. It's not an obvious story. So why do this? What's the point? All of the data isn't the story. All of the data is the context that then lets you tell a story. So in this case, what the actual visualization then does is highlights a particular sector of the economy. So a collection of industries that make up, say, the medical economy. And what it then does is it shows you how those have been performing over this period of time in the context of that hairball of everything else. So all of the data is the context that then tells you how the medical economy is doing in general. So they are doing better because it seems like wages are going up and the number of jobs are increasing. So that's a growth area versus something like this. So this was the housing economy, which is sort of staying the same. Or sorry, the wages are sort of staying the same or going down, and then also the number of jobs are decreasing. So in that case, showing all of the data is not important, doesn't help you, but then it helps contextualize the smaller stories, the smaller points that you're trying to make in the larger thing. And so this is a very useful technique of show everything, provide the context, but then highlight the things that are important to telling the story that you want to tell. Okay, so unfortunately I hadn't realized this is a blog, so there's a number of like online communities that do data visualization, both in the R space and not. This was a group from a number of years ago that used to do these data visualization redesign things. And so somebody would pick a data set and a visualization, usually from the US government, that charitably was not very good. And a bunch of people would take it, redesign it, and then write blog posts about their redesign process and talk about it. And so in particular, there's this blog called The Y-Axis that did a number of these that did a really good job of going through it. Apparently that blog is now dead. It's gone away. So what I've done here is I've just linked the version of that blog from the Wayback Machine, so you can see the version of it that existed as of a year or two ago. But these are, again, older things. But what's really nice here is what you get is the narrative on the left-hand side, and then their iterative process with the design of the visualization as they go through it. And one of the really useful things to get from this is visualization is an iterative process. You don't have the right answer right away. You try things, and you see what works, and then you iterate on that and try something else and keep going. So the narrative is here. You can read through it on your own. What we'll do is just like visualize and go through and talk a little bit about what's happening and what works and not in this particular case. So this is the initial visualization. So what we have here are OECD countries. So from the UN, it's the Office for Economic Cooperation and Development, something like that. But what we have is a visualization of the percentage of employed who are senior managers, and then we have that for men and women split out. So this is the initial visualization, and we have this sort of like weird amalgam of bar plot and scatter plot going on here, even though they're the same thing. Like we're measuring the same thing, just the bars are for men, the dots are for women, but they're measuring the same thing, so it's kind of strange. Sorry, I got it the other way around. Men are the dots, the women are the bars. They're all countries except for the one, which is the one that's highlighted, which is the OECD average. It's the average of all the countries together. So again, this is the initial one. In terms of like difficulties around this visualization, so the choice of the geometries to represent things is a little bit weird. It's making it like it's emphasizing that they're different even though they really aren't. It's just the same thing that's being measured. The countries are on the x-axis and they're hard to read because they're vertical text. They are ordered in a way, but they're ordered based on the proportion of females. But again, that's a choice. You could order by the proportion of males or the difference or something else like that. It's not obvious how you might order it, but at least there has been a choice made. Okay? So that's the status quo where we're starting from and then going through the various visualizations. So the first attempt was basically just to recreate that original visualization in the software, whatever they were using, and I'm not sure what it is off the top of my head. So get back to that original visualization. So looks reasonable. The first attempt was, okay, we can make a dramatic improvement by this by just flipping the axes. Makes the text a lot more readable. But otherwise, that's it. So even something that simple makes this visualization better. Lower cognitive load, we can go through and then do some kind of comparison. Next step is to maybe say like, okay, it's a little bit weird that the men and women are different from each other. So maybe we could use the same geometry to represent both. In this case, creating small multiples. So women on one side, men on the other, still keeping the same ordering we had before. So in this particular case, what does this version of the visualization emphasize? Like, what is the use case for it? Is it better for comparisons within gender or between gender? Yeah, so this is more natural to make comparisons between, say, the United States and New Zealand, something like that within the women, versus it's a lot harder to do a comparison between the United States, women, and men across the board. So again, if that's the use case you have, what you were trying to do, that might make sense, but that's probably not what's trying to be emphasized here. What's trying to be emphasized is more about a disparity between gender representation and upper management between these countries, so we might want to consider something like that. So here, now going to, instead of using bar plots, using dot plots. Again, using 2 bar plots doesn't make sense because they're going to be stacked on top of each other, or at least a little bit hard. So here we do that, and then drawing the line is not necessary, but it's, again, emphasizing visually that these 2 things are connected in a comparison to be made. So now this is more of about a visualization that compares between, within a country, where is the status, what's the proportion between men and women. Again, still highlighting OECD average, keeping the same colors for the most part and the rest. One of the issues here is that there's a bunch of white space, and there's nothing that draws your eye horizontally. So particularly if you pick a country in the middle here, it's a little bit uncertain. Am I picking the right one for Greece here? So one of the ways to fix that is your x-axis doesn't have to be stacked on top of each other. You can move that. So I can just move the labels to be attached to the points themselves. It makes it a little bit harder to read, harder to scan through the countries, but it does make it a lot more clear which country is attached to which set of observation of the data. Continuing on, so then maybe what we can do is try to summarize this in some way, some other kind of comparison about the difference between these. So adding now a small multiple that's another facet, really often what might be like attached to the axis is now the ratio of women to men to compare like how well they're doing. Showing those little bar plots. Also, again, since they're very similar and hard to read and it's small, attaching the numeric value to that, because again, you'd have a hard time recovering those differences accurately. Sort of emphasize that about where they're doing well versus not. And then basically realizing, well, if that's the point of what we want to make, maybe showing both men and women is not important. We can just go back to the simpler thing and just show one larger bar plot of that ratio across the board. And then ordering on that makes it much more natural, again, about which we care about, what shows up. And so I think this is the final plot that they arrived at, have a nice title and other kinds of things. And again, they solve that issue of the white space by now putting the bars so that draws your eye across so you can see. Again, lots of possibilities, lots of options there, but again, this shows you that iterative process, the delay, and the text is, again, very useful for them describing their thought process each step of the way. I'm not doing them justice as I go through. So take a look at that. There's another nice one here going through for another, again, government plot with various industries and weird orderings and coloration. There's also some fun issues of like, you get 3 time points, but one of them is a year apart, the other one's a month apart, so they're like not on even scales. There's all sorts of crazy stuff there. That's not well conveyed in the original plot and then goes through a redesign process to come up with something from it. I won't belabor that. Take a look at it. It's well worth reading. Take 10 minutes to go through the article, but it's a nice redesign process where, again, the original visualization is really problematic to start with. And it is an official U.S. government BLS, Bureau of Labor Statistics thing that was in one of their reports. So there's good examples of just, again, people are not intending to do bad things, they just do. And there are problematic visualizations across the board. They're not trying to deceive, it's just they made bad choices. A couple other things. So other resources that you can avail yourself to now or in the future. So a lot of actually the material I'm using, I am borrowing. So anything good is to them, anything bad is my fault. But at the libraries, there's this Center for Data Visualization Sciences. So it's just a resource there. They run classes. They have drop-in office hours and other kinds of things. And so they're basically librarians whose job it is to help you with visualization, help you find data, help do things with it. Absolutely fantastic resource, incredible people. Go to some of their courses. They run like regular R things and other kinds of stuff. So you can take a look on the website for that kind of thing. Other more general stuff. So on Twitter, there's the DataViz hashtag and Tidy Tuesdays. You can follow those. Tidy Tuesdays is where I got the data set for this week's homework. Every week they release a data set and a bunch of people just create visualizations and do other stuff with them. Super interesting to follow just to see what's going on. They release all the data sets and then there's a bunch of activity on Twitter, people talking about them and posting about it. So it's a great resource just to either sort of lurk and follow along and watch stuff or to participate in. It's a really cool community in the R space. And then there's a bunch of other sort of books and resources. So there's a ggplot2 book. Again, just like all of Hadley's other stuff, is available online, or you can buy a copy. Klaus Wilke's Fundamentals of Data Visualization is great from O'Reilly. Kieran Healy, who's a faculty member here at Duke in the I think, sociology department, also does a bunch of data visualization stuff in R and other things. Also super interesting person to follow on Twitter if you're into like esoteric social science theory and old Macs and a bunch of computer hardware things. He's just a super cool human being. And then Edward Tufte is a famous person in the visualization space. So the Visual Display of Quantitative Information is a famous book in this space that goes into a bunch of like theory about visualization. He has a bunch of other books. He runs short courses. You'll come across his stuff all over the place, but a big name in that space. So again, yeah, all credit to Angela Zoss and Eric Monson for the good stuff that I stole. The bad stuff is my fault. But a number of years ago, we used to have time where we could bring them in and they would do like a couple sessions for this course. It just hasn't worked out in recent years, but they do a bunch of good work. I think Angela's not with the DVS anymore, but if she's not, the people that have been replaced her are fantastic as well. So I will leave it there.